February 1941. The North Atlantic. A merchant ship, the SS Harmodius, wallows in 20-foot swells. Her cargo holds packed with American grain, steel, and aviation fuel. She's 3 days from Liverpool, sailing in convoy HX-112, 41 vessels strong. But the convoy is blind. Above, thick cloud. Below, the black water. And somewhere in that darkness, wolf packs circle. At 3:42 hours, the torpedo strikes amidships. The explosion tears through the engine room. Within 8 minutes, Harmodius is gone, taking 37 men with her. Before dawn, 4 more ships follow her to the bottom. The U-boats vanish before Royal Navy escorts can respond. This isn't an isolated incident. It's a massacre happening every single day in a 1,000-mile stretch of ocean that Britain cannot protect. The Atlantic Gap. A blind spot where aircraft cannot reach, where submarines hunt with impunity, and where Britain's lifeline is being severed, one ship at a time. By spring 1941, the mathematics are brutal. Britain is losing ships faster than they can be built. At current rates, the island will starve within months. Winston Churchill will later write that the U-boat peril was the only thing that ever truly frightened him during the entire war. But in a handful of freezing Scottish airfields, a small group of navigators and engineers are about to attempt something extraordinary. They're going to take obsolete American bombers, strip them down to bare metal, and push them far beyond their designed limits. They're going to close the gap, and they're going to do it before Britain runs out of time. The problem is simple to understand but seemingly impossible to solve. German U-boats operate in the mid-Atlantic, roughly 800 to 1,200 miles from land. British aircraft based in Iceland, Northern Ireland, and Scotland can patrol about 400 miles out before they must turn back to avoid running out of fuel. The same limitation applies to aircraft operating from Newfoundland. This creates a zone, roughly 600 miles wide, where no air cover exists whatsoever. Admiral Karl Donitz, commanding Germany's U-boat fleet, calls it the Devil's Gorge. His submarine commanders call it the Happy Time. For the merchant sailors, it's simply the death zone. In February 1941 alone, German submarines sink 89 ships in the Atlantic. March is worse, 97 ships. April, 107 ships. The curve is exponential. Britain imports 68 million tons of supplies annually. By mid-1941, imports have collapsed to 31 million tons. Food rationing tightens. Fuel reserves dwindle. Aircraft production slows. The chiefs of staff present Churchill with projections that are nothing short of apocalyptic. If the trend continues, Britain will be forced to negotiate surrender by early 1942, not because the army is defeated, not because the RAF has lost control of the skies, but because the island will simply run out of food, fuel, and ammunition. At RAF Coastal Command Headquarters in Northwood, a 34-year-old navigation specialist named Squadron Leader Terence Bullock stares at a map of the Atlantic with growing frustration. Bullock flew reconnaissance missions in the last war and spent the interwar years as a civilian test pilot. He knows aircraft performance inside and out. The problem, he realizes, isn't that suitable aircraft don't exist. It's that they're being used for the wrong mission. The consolidated B-24 Liberator, an American heavy bomber, has exceptional range for its class, around 2,000 miles with a full bomb load and military equipment. But Coastal Command doesn't need bombers over the Atlantic. They need eyes. They need aircraft that can reach the gap, patrol for hours, and force submarines to dive. The submarines themselves are the key vulnerability. A U-boat on the surface can travel at 17 knots, fast enough to intercept convoys. Submerged, it can barely manage 7 knots and has limited battery life. If an aircraft appears, the submarine must dive, losing contact with the convoy. The submarine doesn't need to be sunk. It just needs to be kept underwater. But this requires aircraft that can stay on station, hour after hour, across the entire breadth of the Atlantic. Bullock takes his idea to Air Chief Marshal Frederick Bohill, commander of Coastal Command. Strip the Liberator down. Remove the armor plating. Remove most of the defensive guns. Remove the bomb bay equipment. Install auxiliary fuel tanks in every available space. Bohill listens, then asks the obvious question: how much range could they gain? Bullock does the mathematics on the spot. A standard Liberator carries 2,750 gallons of fuel. With auxiliary tanks in the bomb bay, the fuselage, and even the wing spaces, they could push that to 4,500 gallons, maybe more. That could mean 2,400 miles of operational range, enough to cover the entire gap. Bohill approves the concept immediately, but there's a problem. Britain doesn't have Liberators. The RAF has ordered them, but the first deliveries aren't expected until late 1941, and those are earmarked for Bomber Command. The Air Ministry has no intention of diverting strategic bombers to submarine patrol. Bohill goes over their heads directly to Churchill. The Prime Minister grasps the situation instantly. He overrides the Air Ministry and orders that the first 20 Liberators delivered to Britain will go to Coastal Command, not Bomber Command. The bomber barons are furious, but Churchill is unmoved. Keeping the Atlantic open takes priority over everything else. The first Liberators arrive at RAF Nuts Corner in Northern Ireland in March 1941. They're impressive machines, sleek and modern compared to the lumbering Sunderland flying boats currently used for patrol. But they're configured as bombers, and the modifications Bullock has proposed have never been attempted. The task of converting them falls to a civilian engineer named Donald Bennett, on loan from Imperial Airways. Bennett is 30 years old, Australian-born, and possesses an almost supernatural understanding of aircraft systems. Before the war, he set multiple long-distance flight records and pioneered transatlantic navigation techniques. If anyone can make Bullock's vision work, it's Bennett. He arrives at Nuts Corner on a freezing April morning and immediately sees the scale of the challenge. The Liberator is a complex aircraft, pressurized and equipped with turbo-supercharged engines. Every system is interconnected. Removing armor and weapons isn't a simple matter of unbolting components. It requires recalculating weight distribution, adjusting trim, and ensuring the aircraft remains controllable. And the fuel tanks are the real problem. Adding 1,750 gallons of fuel means adding over 11,000 pounds of weight. That fuel needs to be stored safely, plumbed into the existing fuel system, and positioned so that the aircraft's center of gravity remains within safe limits as fuel is consumed. Bennett assembles a team of RAF mechanics and civilian technicians. They work in unheated hangars, often in darkness due to blackout restrictions. The first task is stripping the bomber configuration. Out come the armor plates from behind the pilot seats. Out come 4 of the defensive gun turrets, leaving only the tail turret for protection. Out comes the Norden bomb sight and the bomb racks. The weight savings are substantial, nearly 4,000 pounds, but the aircraft looks naked, almost fragile. Then comes the fuel system. Bennett designs a series of self-sealing rubber tanks to fit in the bomb bay. Additional tanks go into the fuselage, carefully positioned around the aircraft's center of gravity. The engineering is painstaking. Each tank must be tested for leaks, then integrated into the fuel management system. The pilot will need to manually transfer fuel from auxiliary tanks to the main wing tanks during flight, a delicate process requiring constant attention. Get it wrong, and the aircraft could become nose-heavy or tail-heavy, potentially uncontrollable. Bennett develops a fuel management chart, a complex table showing exactly when and how much fuel to transfer at each stage of the mission. Pilots will need to follow it religiously. By May 1941, the first modified Liberator is ready for testing. Bennett takes it up himself, accompanied by a test crew. The takeoff is nerve-wracking. The aircraft is heavy, sluggish, and the engines strain. But once airborne, she handles reasonably well. Bennett flies a simulated patrol route, monitoring fuel consumption, engine temperatures, and aircraft handling as fuel burns off. The results exceed expectations. With careful fuel management and cruising at economical power settings, the modified Liberator can stay airborne for 16 hours and cover 2,400 miles. It's enough. Just barely, but enough. The Atlantic gap can be closed, but there's no time for celebration. The losses continue to mount. In May, 58 ships are sunk. The convoys are being slaughtered. Coastal Command needs these aircraft operational immediately, and they need crews trained to fly them. The training problem is substantial. The Liberator is an American aircraft, unfamiliar to RAF pilots. It's faster and more complex than anything most of them have flown, and the modified versions require constant attention to fuel management. A moment's inattention, and a crew could find themselves hundreds of miles from land with empty tanks. Squadron leader Hector Belitho, a veteran patrol pilot, is assigned to develop the training program. Belitho has logged over 2,000 hours in flying boats and understands the peculiar demands of maritime patrol. It's not glamorous flying. It's hour after hour of low-altitude work, often in terrible weather, scanning empty ocean for tiny periscope wakes or oil slicks. The modified Liberators add new complications. The fuel management system requires one crew member to do nothing but monitor tanks and transfer fuel. Navigation over the featureless Atlantic demands precision. An error of even a few degrees could mean missing a convoy entirely or running out of fuel before reaching land. Belitho drills his crews relentlessly. Navigation exercises, fuel management drills, simulated searches. The crews are exhausted, but they understand what's at stake. Every day they spend training, more ships are dying in the gap. By June, the first operational crews are ready. Number 120 Squadron, based at Nuts Corner, receives the first 3 modified Liberators. They're designated Mark I's, and the crews immediately nickname them Very Long Range Aircraft, or VLRs. On June 13, 1941, Flight Lieutenant John Eccles takes off on the first operational VLR patrol. His mission: fly 1,100 miles west to the mid-Atlantic, patrol for 4 hours, then return. Total flight time, 15 hours. Eccles and his crew understand they're flying into history. If this works, it changes everything. The flight is grueling. At 5,000 feet, the Liberator drones westward through broken cloud. The navigator, pilot officer James Ray, works continuously, taking sun shots when the clouds break, calculating drift, updating their position. The wireless operator monitors convoy frequencies, listening for distress calls. The fuel management officer, Sergeant Kenneth Mills, transfers fuel from auxiliary tanks every 30 minutes, carefully following Bennett's charts. After 6 hours, they reach the patrol area. Below, the Atlantic stretches empty and gray. Eccles descends to 1,000 feet and begins a systematic search pattern. The crew scans the water through binoculars, looking for anything. A periscope, a surfaced submarine, and oil slick wreckage. For 3 hours they see nothing. Then at 14:20 hours the front gunner spots it. Awake, white against the gray water. Eccles banks toward it. As they close, the shape resolves. A submarine running on the surface heading northwest. Eccles doesn't hesitate. He pushes the throttles forward and descends. The submarine's conning tower watch spots them at the last moment. Alarm bells sound. Men tumble down the hatches. The submarine begins its crash dive. Eccles roars overhead at 200 feet. They have no bombs, no depth charges, but it doesn't matter. The submarine is diving, forced underwater, losing contact with whatever convoy it was hunting. Eccles circles, marking the position. The submarine doesn't resurface. After 20 minutes, Eccles resumes patrol. They stay on station for another hour, then turn for home. The return flight is tense. Fuel is tight. Mills transfers the last reserves from the auxiliary tanks. The engines drink fuel steadily. As they approach Northern Ireland, the tanks are nearly dry. Eccles brings the Liberator down at Nuts Corner with less than 200 gallons remaining. The crew climbs out exhausted but elated. They've proven the concept. The Atlantic Gap can be covered. Throughout June and July, more VLR Liberators enter service. Number 120 Squadron expands. New crews complete training. The patrols become routine, though routine is a relative term. Each mission is a 14 to 16-hour ordeal of concentration and endurance. The crews fly in unpressurized aircraft, often through violent weather. Icing is a constant danger. Navigation errors can be fatal, but the impact is immediate and measurable. In June, ship losses in the mid-Atlantic drop by 22%. In July, they drop another 18%. The U-boats are being forced to operate submerged, cutting their effectiveness dramatically. Donitz notices immediately. His war diary entries from July 1941 show growing frustration. His commanders report aircraft appearing in areas that should be beyond Allied range. Attacks are being interrupted. Convoys are escaping. He demands answers from German intelligence. How are the British doing this? German reconnaissance eventually photographs the modified Liberators at Scottish airfields. Donitz realizes what has happened and orders his submarines to operate even further west, beyond the new aircraft range. But the VLR patrols keep extending. By August, Coastal Command is operating from Iceland as well as Northern Ireland, pushing coverage even further into the Atlantic. The work at the Scottish and Irish airfields is relentless. Ground crews service the Liberators around the clock. Each mission requires extensive preparation. Fuel tanks must be topped off, engines inspected, navigation equipment calibrated. The aircraft return from patrol with salt corrosion, weather damage, and mechanical issues. Maintenance crews work in freezing conditions, often outdoors, keeping the aircraft flying. Donald Bennett, now promoted and overseeing the entire VLR program, pushes for continuous improvements, more fuel capacity, better navigation equipment, improved crew comfort for the marathon missions. By September, the modified Liberators are carrying 4,800 gallons of fuel, pushing operational range to 2,600 miles. The gap is closing, but it's not closed yet. There are still areas where submarines can operate with relative safety, and Donitz is learning to exploit them. The battle is far from over. In September, a VLR Liberator from No. 120 Squadron, piloted by Flight Lieutenant David Istid, encounters a wolf pack attacking convoy SC-42. Istid arrives to find chaos. 3 merchant ships are burning, 2 more are sinking. Lifeboats dot the water, and on the surface, clearly visible, are 2 U-boats moving in for more attacks. Istid has 4 depth charges, a recent addition to the VLR armament. He attacks the nearest submarine, dropping 2 charges as it crash dives. The explosions erupt astern of the swirl. Istid doesn't know if he scored a hit, but the submarine doesn't resurface. He circles, preventing the second submarine from attacking until Royal Navy escorts arrive. The convoy survives. Istid's intervention saves potentially a dozen ships. By October 1941, the statistics tell the story. Ship losses in the mid-Atlantic have dropped by 40% compared to the spring. The VLR Liberators aren't sinking many submarines, but they're achieving something more important. They're denying the submarines the ability to operate effectively. The mere possibility of aircraft appearing forces U-boats to remain submerged, reducing their speed and limiting their ability to find and track convoys. The psychological impact on submarine crews is significant. German war diaries begin reporting strain and exhaustion among U-boat commanders. The happy time is over, but the VLR program faces constant challenges. The Air Ministry continues to pressure Coastal Command to release Liberators to Bomber Command. Every aircraft is desperately needed for the strategic bombing campaign against Germany. Churchill must repeatedly intervene to keep the VLRs flying Atlantic patrols. There are never enough aircraft, never enough crews. The men fly mission after mission, exhaustion accumulating. In November, a VLR Liberator disappears over the Atlantic. No distress call, no wreckage found, 14 men gone. The crew had been flying continuous patrols for 3 months. Fatigue may have been a factor. Navigation error. Mechanical failure. The ocean keeps its secrets. By December 1941, the strategic situation transforms. Japan attacks Pearl Harbor. America enters the war. Suddenly, the Atlantic battle takes on new dimensions. American ships, American aircraft, American resources begin flowing across the ocean. But the U-boat threat intensifies as well. Donitz receives more submarines. He begins operating off the American coast, where defenses are weak. The VLR Liberators become even more critical. Through the winter of 1941 and 1942, they maintain their patrols, extending protection to convoys in the worst weather of the war. The crews endure conditions that are barely imaginable. Temperatures inside the unpressurized aircraft drop below freezing. Ice forms on the windows. The constant drone of engines, 14 hours at a time, is physically painful. But they keep flying. In February 1942, exactly 1 year after the crisis began, Coastal Command reviews the statistics. In the areas covered by VLR patrols, ship losses have dropped by 63% compared to February 1941. The innovation has worked. The Atlantic gap, while not completely closed, has been dramatically reduced. The lifeline to America remains open. The story of the VLR Liberators is ultimately a story about innovation under pressure. Britain in 1941 faced an existential threat, one that couldn't be solved by bravery alone or by simply fighting harder. It required technical innovation, creative thinking, and the willingness to take risks with unconventional solutions. Squadron leader Bullock's insight that patrol aircraft didn't need armor or bombs. Donald Bennett's engineering genius in making the modifications work. The courage of crews who flew missions at the edge of what was possible. All of these elements combined to solve a problem that had seemed insurmountable. The VLR program saved thousands of lives, hundreds of ships, and quite possibly saved Britain from defeat. By 1943, with more aircraft available and bases in the Azores, the Atlantic gap was finally closed completely. U-boat losses soared. The Battle of the Atlantic turned decisively in favor of the Allies. But the turning point came in those desperate months of 1941, when a small group of innovators at Scottish airfields took obsolete bombers and transformed them into the aircraft that kept Britain alive. The modified Liberators flew patrols until the end of the war. Some of the original crews survived to see victory. Others did not. Their contribution is often overlooked in histories that focus on fighter aces and bombing raids. But without them, without those grinding 16-hour patrols over empty ocean, there would have been no victory to celebrate. The Atlantic would have been lost, and Britain would have fallen. The next time you consider what won the Second World War, remember the men who flew the VLR Liberators. Remember the engineers who stripped down bombers in freezing hangars. Remember that sometimes the most important victories come not from dramatic battles, but from technical ingenuity, determination, and the willingness to attempt the impossible when everything depends on it.